Hello and welcome to this video. So we are now on KVL, Kirchhoff's voltage law, and we are going to be solving this circuit. He said in this circuit you should find IL and VM. There's a current flowing through here, and there's a voltage here. So how do we do that? We apply KVL. Remember KVL law and Kirchhoff voltage law says that the sum of voltage in a closed loop, the algebraic sum of voltage in a closed loop must be equals to 0. So the first thing that we do is that we identify our nodes. Here we have three mesh, because a mesh is a loop that cannot contain any other loop. You see this rectangle is a whole loop that consists of three meshes. So this is a mesh, this is a mesh, and this is a mesh. We have three meshes inside this whole loop. But the reason why we call it loop is that when we are solving, so we don't get confused. So we have nodes also. This is node 3, node 2, node. We have three nodes here that we are dealing with. But should I say 4? We have 4 nodes, because since this is a loop, this is a loop, and this is a loop, we want to solve here, here, and here. So we have to count this also, and count this also as a node. Do we get it? So if this is a node, this is a junction, because it's already 3 circuit element that is passing through it. This is also a junction too. This is a node. So let's now start. How do we remember? Like I said in the law, sum of voltage, the algebraic sum of voltage in a closed loop must be equals to 0. So that's what we are using. So for node 1, for this node 1, you have it that the voltage here, the voltage acting that is flowing here, that's V43, and the voltage here, this is the ground level, 0, plus V30 plus the voltage. There's no voltage here, so there's another voltage here which is showing V04 must be equals to 0. Now for this V004, they have given us our voltage already, but for this we only have the current and the resistance, and from the Ohm's law we can use V is equals to IR to get our voltage here. So that's why it is called voltage law. So we are going to be using V is equals to IR. Remember in KCL, know that we are using I is equals to V over R to get the for each current. Do you get? But for now, for each voltage, we are going to be using V is equals to IR. So now for the second loop, node 2, I should use loop, not load. So for loop 2, we have this V32 plus V20 plus, there's no any voltage here, so V03 is equals to 0 also. Then for the last loop, it should be loop 3. So V21 plus V10 plus V0, there's nothing here, plus V02 also is equals to 0. Now we now start bringing out the voltage. The one that doesn't have voltage, we use the word IR. So let's get started. From here we have loop 1 now. So what is the voltage in V43? What is the voltage? You know this is 43. What is the voltage here? We are given I and we are given R. So our I is I1 in this case, in this loop. So I1 multiplied by 2 ohms. So that will be 2I1 plus. Now in this place, in this V30, you have to be very careful. This resistor here is serving for this side and it's also serving for this side. So you have to get the difference of the currents and divide it by that single resistor. So what am I saying? We are going to have 5 into brackets I1 minus I2. We are dealing with this loop, that's why this I1 is coming first. So I1 minus I2 divided by 5. Then for this one, we already have the voltage already. We just put down plus 25 is equals to 0. So let us simplify now. We have 2I1 plus 5I1 minus 5I2 is equals to minus 25, since that one is given to us already. So we have I1, this one will be 7I1 minus 5I2 is equals to 25. If this one is equation 1, equation 2, equation 3, this one will be equation 4. So do we get? So let's use loop 2 now. Our loop 2. Loop 2. What do we have in loop 2? This is loop 2. So we deal with V32 first. And what is that? It's going to be I2 multiplied by 2. So that's 2I2. 2I2 plus 2 and 0. What are the voltage there? We have IR, I2 and I3. This resistance is same for both sides. So it's going to be what? I2 minus I3 divided by 4 ohms. So that will be 4 into brackets I2 minus I3 and plus, now be careful here also, V03 from ground level to this 3 to this junction. You have this 5 voltage serving for this side and this side. But note that this is the loop that we are considering. So this I2 that is going to be coming first. It's going to be I2 minus I1 divided by 5. So do we get it? So it's going to be 5 5 multiplied by I2 minus I1 rather. No, it's IR we are dealing with. I'm just putting that R at the back so that we can arrange it very well. I2 minus I1. So what is left now? Nothing is equals to 0. So let's simplify. 2I2 plus, let's bring this out. We have 4I2 minus 4I3 plus 5I2 minus 5I1 is equals to 0. So let's now check the one that is the same thing. We have 3I2 here, I2. Let's bring them to one place. So I2 into brackets 2 plus 4 plus 5. Are we following? So then we have an I3. We have I1. Okay, let's pick I1 first. You can pick anyone first. Then we have I3 is equals to 0. So when you want to pick it in your matrix, I know that this is I2, then this is I1, and this is I3. So for the third loop, this is equation 5. For the third loop, we are going to be focusing on this loop, and this the voltage for this 2 1 will be what? IR, so it's going to be I3 and times multiplied by 1. So that's 1 open brackets I3 or 1 I3, still the same thing. Then plus, dealing with this, that's I3 multiplied by 6, that's 6 I3. What do we have here? This 4 resistor 4 ohm is acting for this side and this side. So that will be I3 minus I2 multiplied by 4. So that will be 4 into brackets. I3 is coming first because it's the loop we are dealing with, minus I2. Okay, so now this should just be, let me put that one there because I don't want to confuse. So plus okay, we want to bring that one out. I3 plus 4I3 minus 4I2. Do we get? So what are we having that is common? We have 3I3 that we can bring together. So let's bring that one together. We have I3 into brackets 1 plus 6 plus 4. Then minus 4I2 is equals to 0. So that is our equation 6. So can we see we can now bring this we bring this and this out into our matrix. So when we do that, we'll be able to solve out our current. When you are dealing with KVL, we are solving for current, and when you are dealing with KCL, we are solving for voltage. So Okay, so now this is the first equation. So we are bringing it outside into our matrix form. This we normally call it Cramer's rule. Everybody will have been familiar with that. So we use it last time when we were solving KCL. So this is our I1. For here we should be having I1, I2 and I3. So this place will be for the results. No, is equals to. So the result for this is minus 25. The result for the second one is 0. The result for the second one is 0. So minus 25, 0 and 0. I'm picking it from each answer that we got. You see. So now let's now pick I1 for this one. Do we have I1? Yes, I1 is 7 here. 7. Then I2 is minus 5. I2 will be in the second place. Do we have I3 here? No. Put 0. Then go to the next one. We have I1, right? Minus 5. And minus 5. After minus 5, do you have I2? Yes, we have I2. Our I2 is 2 plus 4 plus 5. So 2 plus 4 is 6. 6 plus 5, that's 11. 11. So I3 is what? Minus 4. Very, very interesting. So you have I1 here? No. So you put 0. I2 is what? Minus 4. And I3 is what? 1 plus 6, 7 plus 4, that's 14. That's 11 rather. 11. So we are now going to be calculating. This is our delta. Just like we did the last time, we are going to be calculating for each of the, for each of the currents that we are looking for. So remember, I1 will be what? Delta 1 over delta. Then I2 will be what? Delta 2 over delta. And I3 will be what? Delta 3 over delta. Very, very interesting. So when you solve for the normal mean determinants, I mean the whole of this, you will get your delta. After that, when you want to get for delta 1, take this 1 by 3 matrix, come and place it here. Calculate for the determinants. That will be your delta 1. After that, take the same 1 by 3, slot it in the middle, use it to replace this, then calculate it, you get your delta 2. Do the same thing for the third row, calculate it and get your delta 3. Then now use it to solve your currents. So when you get your current 1, you will now know the one. By getting your current, you already know the one that is I1, IL, and how you calculate your VL, because you are, or no, at this side you already have a resistor here which is 6. So once you get all the currents now in this third loop, you already know the one that belongs here, so you can just calculate this. Maybe the one that we just use IR, since you have known the I here, just multiply by this and get our answer. And for this one, we'll already get current already. So in the next video, we are going to be doing that. We are going to be solving for the IL and VL. We'll be picking it from the answer when we get our final answers. Thank you very much. In the next video, please like, comment and share. Also subscribe and help us send to